In our first neutralization reaction, we're going to do 3 steps to solve it. First step, we're going to want to find the moles of the known. We're going to want to confirm the ratio of the hydroxide to the hydronium ion, and or the H plus, the proton. And then finally we're going to have to solve for the unknown. It's a good idea to just sort of gather up what do we know, what do we don't know. So the moles of the known are the things that we know everything about. So in this case, it's the potassium hydroxide. We know the molarity, the concentration, and we know the volume of it. So our first step will always be with the thing that we know about. And then the second one, solving for the unknown. The unknown is what the question's asking us. How many milliliters? So it wants to know the volume, and they're giving us the concentration. So ultimately, we want the volume of the HCl. And they told us that we want it in milliliters. So let's begin with what we know. We are given a 0.75 molar or moles per liter solution. And we're told that we have been using 0.025 liters of it. This is sort of a side calculation in converting milliliters to liters. So be assured that every time you do your concentration, every time that basically that you set it up and you're using your volume, that you're showing it in liters instead of milliliters. So the thing that we're solving for here is moles. How many moles of the OH is going to be inside of 0.025 liters. So we're going to cross multiply 1 times X and our volume times the moles. And so we're going to get 0.01875 moles. So this is going to be the number of moles of KOH. Now the KOH itself has dissociated. So as part of our ratio step, we want to, verify our proportions. So the potassium hydroxide is sort of dissociating into a 1-to-1 ratio, where there's 1 mole of potassium hydroxide and 1 mole of OH that's produced. And with the hydrochloric acid, it will also dissociate in a 1-to-1 ratio. So the OH to H ratio will be 1-to-1. And so if we know that at the point of neutralization, there's 0.01875 moles of OH, we could safely say, therefore, there's 0.01875 moles of the hydrogen ion as well. Now we're on to our last step, which is solving for the unknown. Every question kind of looks a little bit different at this point, but we are looking for the volume of the hydrochloric acid in milliliters. So let's write down what we do know. We do know that there's 0.45 moles in 1 liter, because we know the concentration, the molarity. And we just found out here how many actual moles there were at the point of neutralization, which is when the proton is equal to the amount of the proton is equal to the amount of the hydroxide. But the question is, how many milliliters? So this is where we're going to put our X for our volume. It's a little bit of a trickier sort of math to get the X out of the denominator. We'll do a little bit of cross multiplication. X times 0.45 and 1 times our moles. Now to get X by itself, we will undivide, if you will. Which brings us to 0.0416. This amount is in liters, and our question does ask for milliliters. So I'm just going to make that quick conversion. If you divide by 1,000, that will give us 41.6. This is a repeating milliliters. And so in terms of this scenario, if I add 41.6 milliliters of hydrochloric acid to 25 milliliters of 0.75 molar potassium hydroxide, I will get to a position of neutralization where the number of moles of H and OH are equal.